Welcome to qnawire.
Here we have functions f and g. Let's start by adding them. So f plus g would be the square root of 3 minus x plus the square root of x squared minus 1. And these are not like terms. There's really nothing we can do to combine those together. F minus g will be the square root of 3 minus x minus the square root of x squared minus 1. Again, there's no simplifying to do here. Now let's talk about the domains. So what's the domain of f? Well, we know that we have to have the square root of a non-negative number, so it has to be the square root of 0 or a positive. So that means that x could be 3 or anything less than 3, but not more. So the domain of f is x is less than or equal to 3. What about the domain of g? Same idea. Inside the radical, we have to have 0 or a positive. That will happen if x is 1 or greater, or if x is negative 1 or smaller. So the domain of g is x is greater than or equal to 1, or x is less than or equal to negative 1. Now, to find the domain of f plus g, f minus g, and f times g, we need the intersection of these two domains. So the intersection would be the overlap, what they have in common. So for both sets, it would be okay for x to be less than or equal to negative 1. And if I write that in interval notation, that would be negative infinity to negative 1. But then if we combine these two ideas here, less than or equal to 3 and greater than or equal to 1, we get the interval from 1 to 3. Square brackets to include the endpoints. So we'll get the same answer for the domain of f minus g. And the same answer for the domain of f times g. We can just rewrite those domains up here. For f, it was x is less than or equal to 3. And for g, it was x is greater than or equal to 1 or less than or equal to negative 1. Okay, now let's find the product f times g. So we have the square root of 3 minus x times the square root of x squared minus 1. Now we could combine these into one single square root sign. So we have the square root of 3 minus x times the quantity x squared minus 1. And we could go ahead and multiply that out if we want to simplify it. So using the FOIL method, we would have 3x squared minus x cubed minus 3 plus x. And if we want to put those terms into descending powers of x, we have the square root of the opposite of x cubed plus 3x squared plus x minus 3. Okay, let's go to another slide for f over g. So we're going to take function f, which was the square root of 3 minus x, and divide it by function g, which was the square root of x squared minus 1. We could write those inside a single square root if we want to. And I suppose if we were really interested, we could rationalize the denominator, but typically in calculus, you're not required to do that. So we'll call this f over g. Now, how about the domain? So remember in the previous problem, all we had to do to get the domain of f plus g, f minus g, and f times g was to find the intersection of the two separate domains. But that's not the case for the quotient. For the quotient, you also have to consider that g cannot equal 0 because you can't have 0 in the denominator. That means we can't have x equals 1, we can't have x equals negative 1. So then when we write that intersection, we can write it as, so this is the domain of f over g, we can write it as negative infinity to negative 1, but we have to have an open bracket to show we're not including the endpoint, union, and then we can have an open bracket on the 1 as well. We can still have a closed bracket on the 3 because it's still okay to have a 3 on the top and have the numerator be 0. It's just not okay for the denominator to be 0.